Hi, and welcome to Software Design Development, Option 2, Lesson 3, Hexadecimal Conversions. Here are the dot points, pause if you'd like to read them. So, hexadecimal is base 16, and it comes from Latin. Hex is 6, decimal equals 10, and it uses the numbers 0 to 9 and letters A to F to represent digits. A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. It's a convenient way of storing and dealing with large numbers. So 1 byte is 8 bits, which is 2 groups of 4 bits. And 4 bits will equal 16 possible values, which is also 1 hexadecimal digit. So it's a really nice way of combining binary and big numbers together. We can represent a lot more values in a smaller space with hexadecimal, but it also works really well with binary when we're converting. So here's the hexadecimal place value table, and we'll be using this for our conversions. And I find it's easier to remember the powers of 16 than the numbers. You might be the other way. It's up to you. You'll need to know both of those when you convert though. So when we're converting from binary to hexadecimal, we need to use both our binary and hexadecimal place value tables. We previously used this example of 205 base 10, so we'll use that again. And the binary representation of this is shown below. Step 1 is to write the number in your binary table, and we've done that there. Okay. Step 2 is to split the number into 4 number groups, starting at the right. If we find we can't make a 4-number group, we add zeros from the left. In this case, it works out evenly. And so, we take these 4 numbers, because they're the 4 from the right, and we write them down below. Alright, and then we convert those to, we work out what they are. So 1101, that actually adds up to 13. We then convert that to a hexadecimal digit, so 13 becomes D. Step 4 is to convert the next group of digits. So we take these ones here, we write them in the table, 1100, and we find out that actually equals 12. Convert that, 12 is C. And so that's our hexadecimal number, CB, base 16. Okay, so to convert from hexadecimal to binary, the process is the exact reverse. We're converting 3D1. First thing we need to do is convert the 1. Okay, so 1 divides into 1 once with no remainder. We write 1 there. To make the other digits up, we add zeros. So now we have 4 digits that represent this number 1. The next one we need to convert is D. And so 13 divided by 8. 13 goes into 8 once with a remainder of 5. Then we convert 5. 5 goes into 4 once with a remainder of 1. And then it doesn't go into 2, but it does go into 1. And so that's our number there. Lastly, we have to do 3. And so 3 will go into 2 once with 1 remainder. And then 1 goes into 1 once with no remainder. And obviously to fill in the 4 digits, we put 2 zeros. For the next step, we need to expand our table. Okay, so you can see I've done that here. And we then combine our 3 4-bit groups into a 12-digit number, and we work from right to left again. Alright, so we can see our numbers here. And what we do is we put this number first, because that's the first number that we looked at, which was the least value from the hexadecimal, the 1. Okay, and that goes there. Then we take the D, 1101, and that goes in the next slot. And then we take the 3, and that goes in the far slot, 0011. Okay, so we get our number 001111010001 base 2, and then we drop the zeros up front. We get 1111010001 base 2. Converting from hexadecimal to decimal, we follow the same process as converting from binary to decimal. We multiply the digits by the decimal equivalent of the place. So looking at AB3 up here, we say that A is, we times A by 16 squared, we times B by 16 to the power of 1, and we times 3 by 16 to the power of 0. Converting that, A equals 10, so 10 times 256, B is 11, 11 times 16, and 3 is 3, so 3 times 1. Okay, and we add those up, 2560 plus 176 plus 3 gives us 2739 base 10. If we're converting from decimal to hexadecimal, we follow the same process as converting from decimal to binary. We divide and subtract. So I'm going to convert 14,632 decimal, and we're going to convert that to hexadecimal. So we divide 14632 by the highest number in the table, and for us we got 4096. 14632 divided by 4096 equals 3, and some remainder. To work out what that is, we times 3 by 4096 to get 12288, and then we minus 14632 minus 12288, and we get 2344. And that's the number we're going to use for the next step. So dividing 2344 by the next number, by 256, we get 9. So 2344 divided by 256 equals 9, and some remainder. So to work out what the remainder is, we do 9 times 256, and that's 2,304. And so 2,344, which is our original number, minus 2,304, which is 9 by 256, will equal our remainder 30. Then we divide 30 by the next highest number, which would be 16. So 30 divided by 16 is 1, and the remainder, 1 by 16 is 16, 30 minus 16 is 14. And then we work out what 14 divided by 1 is, which is obviously going to be 14. Convert that to a hexadecimal digit, which is E.